Welcome to the CordaCodeClub presentation for CordaCon2020. Today, you will witness two teams of Corda initiates battle it out before our judges to win the highly coveted Best CordaCodeClub Corda 2020. Over the last 7 weeks, two teams have been working their socks off to design, to develop, and then to put into production the first publicly available Corda slot machine Corda. The challenge set was simple: to build a slot machine Corda in your spare time over the course of 7 weeks that was decentralized, fun, and working, so that anyone could play it from anywhere. And as you can well imagine, ladies and gentlemen, this challenge has been grueling. From our initial group of 15 members, only 6 have made it through to the final today. They are the Wizards: Xavier Lepretre, Chris Wells, and Dimash Danabek. And then Team CoSMA: Yash Karkera, Florian Pautot, and Awie. And to determine which team will go home with the prize, Best CordaCodeClub Corda 2020, we are delighted to have the following judges. We have CoSMA, Payments Product Manager at R3, Richard Crook, Director of Lab 577, and Ryan Gledhill, the CTO of IVNO. Okay, without any further ado, let us start with Team 1, CoSMA.
Good afternoon and welcome to Team CoSMA's CordaCon2020 CCC Slot Machine Challenge, prepared by Florian, Awie, and myself. Our goal was to develop a decentralized slot machine based on the Corda in 6 weeks, and we did it. What we've designed is a fair and secure slot machine framework which supports a decentralized casino workflow and simulates a casino franchise on a Corda network. It has built-in redundancy and hence it offers resilience. The system architecture comprises 3 casino nodes connected to the notary. Each casino can be accessed through a Springboard gateway. The entire app is hosted on the AWS. So when a user, and you see there are 3 gambler users here, launches the application on his internet browser and makes a spin, the request is sent to the Springboard gateway to the nodes, and in case of a contract, goes back to the notary and back. We'll now take a look at the design and the workflow, for which I would like to invite Awie.
Thanks, Yash. I'm Awie. I will be taking you through some of the states, nodes, and flows that we have in the application. Starting with the states, we have the user state that comprises the player state, and account info is the user's account that's created at startup. The token is the fungible token that the currency that we use to play the game. Then the casino deposit is the casino's deposit into the game. The casino also has a stake deposit, which is part of our proof of stake implementation, where every casino needs to do that deposit before being able to participate. The game state is around the game flow itself and the outcome. And then we have the game config, which is the metadata for the game, like the reels and the combinations that it uses. And then we move on to the nodes. As you can see, we've got multiple nodes there, which ensures the redundancy we spoke about earlier, and also the sharing of the risk between the different casinos. And then we've got the notary to ensure that we don't have any double spends, as is true for any Corda application. For the flows, as you can see listed there, I'll take you to the next slide, which describes it in a bit more detail. You can see that at the top, we have create casino account flow. This is our system startup. Essentially, the casino accounts are created and the stake accounts are created for those casinos. And issue game config flow is basically, like I said, the metadata for the game that's created there. The issue user flow is when a user is registered onto our system, which also goes along with creating the various accounts, the user account and the reserve account for that user. And then once the start game flow from the user's perspective is made, he first has to reserve tokens for this game. That's the reserve token flow. This, as you can see, the other arrows indicate there that this reserve token is also communicated through to the other casinos as well. They're also aware that the user has the tokens now to be able to play the game. And then the generate result for the game flow is where randomly we generate the outcome, shared with other casinos there at that point. And to finalize at that point, we also pay out, we allocate the tokens to the user if he's won the game, otherwise it's reallocated back to the various casinos.
Thank you very much, Awie. My name is Florian, and I will be your guide through this CoSMA slot machine experience. So you can basically spin the game until you actually get like a success, or your balance is just to 0. And to generate a result, we use a deterministic random generation. That means that we use a seed to actually generate the combination, and the initiating casino will send that combination to the other nodes. The other nodes will also generate it, validate that it's the same, and once it's the same, it will be committed into the game state. So yeah, basically that's it for the slot machine. It's well, a classic slot machine, I would say. One addition we added was to put a kind of node explorer. So the node explorer will allow you to actually access the DLT and to be able to see all the states, the transactions, and the cartography of the network. So I'm currently logged in on the Casino A. So I can see all the core apps that are actually installed on my node. I can see some information about the network, the notaries that we have. We also have a kind of nice map, which is showing where the nodes are located. So we can see that we have a casino in New York, that we have one in Paris, and one in London, and that the notary is also located in London. So we also have access to the transactions. And in this transaction, you will be able to see the actual, well, process for the game. So as Awie said, the first step is to actually create the game with the start game flow. So we can see that in the game, we have information about the user and its account. And we also have access to, well, more information on the game, so the stake, which step it is currently at. So for now, that's for the game creation. So once the game is created, we will do some token movements. So from the user, it will be logged into the reserve accounts. And from the casinos, it will also be logged into the reserve accounts. And as we already said, we want to mitigate the risk and the rewards. So that means that all the casinos will lock the maximum reward that the user can win. And they will split that between the number of casinos, and each casino will actually lock a part of the maximum reward. Once we will have done this token movement, we will actually update the game to say that the token has been reserved. Once it's done, we will generate the results, and based on the results, trigger the resulting movements. And that means that from the casino to the users, if the game has been won or if it's lost, all the casinos will actually share the stake. And then the state will be updated, the game state, with the resulting combination, and with the new step, which is finished in that case. So we also have access to the different states on the nodes. So in that case, we can see that we have the casino deposits, which are the total amount that has been put by the casino. We can see that each casino really has staked some money into the stake share accounts. And yeah, basically we have access to all the states. We can see the different games by all the users and different steps of their life cycle. So the goal for our slot machine was really to create a kind of franchise decentralized Corda network and to allow the casinos to have as many interactions as possible in this slot machine workflow. And the goal was to really have active interaction and not just passive interactions between all the nodes, and to be able to mitigate the risk and share the different rewards on the different casino nodes. So I will now let Yash do the conclusion note.
Well, I hope you enjoyed our presentation and found our value proposition compelling. We thank you for your time and invite you to try to play and win at our casino. Enjoy the rest of the afternoon and all the best.
All right, so these guys have proven it works.
Yeah, okay, that's very cool.
The explore me bit's quite neat.
That is cool. I'm highly impressed by that.
Yeah. Richard, how have you managed to net the 1,000 token prize?
Yeah, yeah. And I'm only 50 here, though.
In life, Case, there are always greater and lesser people.
Welcome to the Wizards Team project. For this slot machine project, we wanted to demonstrate how Corda can alleviate trust issues between parties and how it can enforce outcomes by contract. At its most basic, this game has two parties, the casino and the player. The casino wants to offer a game of chance to the player, but they do not trust each other so much and would like to find ways to protect themselves, which is why we chose to implement it this way. First, we took the odds of the game of chance from the given GUI, which you can see here. In effect, we need a number between 0 and 10,000, or more precisely 0 and 9,999. Now, if the player trusted the casino fully, it could let the casino pick this number randomly, but of course, the casino could then pick a number that is more profitable to it more often than the agreed odds. Similarly, if it was the player who picked the number randomly. So we opted for a combination. Both participants create a random number on their own, and these two numbers are then combined together to get the final random number. Then, to make it harder to reverse engineer the outcome, we use a hash and a modulo. From here, how do we protect the participants from further cheating? If the casino revealed their random number to the player first, then the player could adjust their own random number to be more profitable. After all, it doesn't even need to test 10,000 numbers. It would take a fraction of a second. Similarly, if the player revealed first. We could use a trusted third party, but that defeats the idea of decentralization. So what we need is a sealed envelope mechanism, the so-called commit-reveal pattern. In the commit phase, both parties commit to a random number, or rather the hash of it, so that it cannot be reverse engineered. At this point, a finalization of some sort has to happen. With Corda, that is a transaction, and we call it the commit transaction. Then both the casino and the player move on to the reveal phase. This happens in two independent transactions that we call reveal transactions. When both numbers are revealed, then it is possible to resolve the game in what we call the resolve transaction. What about the reward? Here, the losing party could try to walk back and refuse to sign off on the payment. So we chose to lock the reward tokens as part of the commit phase and to release them when resolving the game. And yes, when the tokens are locked, they are locked within the game and are no longer owned by anyone else. It is the game that will decide how the winnings are split within the resolve transaction. Okay, we have now the outline of the 4 transactions that make up one game. Let's dive a bit into the details. The commit transaction takes tokens in, typically 1 from the player and 199 from the casino. And it does not forget to return the change if the token states were too large. It creates 2 committed states that each contain the casino's and the player's hashes to which they commit, plus a game state and a locked token state which are encumbered to each other. Why encumbered? Well, the locked tokens do not belong to anyone, so they are at risk and could be released without signature by whoever is the fastest to cheat. Instead, by encumbering the locked token with a game, we make sure that the game contract accepts only a resolved transaction that abides by the rules of the game. Each revealed transaction then consumes the relevant committed state and creates a revealed state with the original random number, whose hash has to match the committed hash, obviously. The reveal deadline is enforced by picking it from the game passed as a reference. When both committed states have been revealed, it is then possible to move on to the resolve transaction. Note that anyone can generate and sign this transaction. That's because it is all controlled by contract, both the winnings calculation and the payment of it. Now, this happy path for transactions has to be enabled by flows, which we will see in a second, and our choice was to have the player orchestrate the flows. This is reflected here in the color code. Pink is for the player, who generates 3 out of 4 transactions. On to the flows. As you can see, we have split the swim lane diagram into 3 broad zones, which represent the commit, reveal, and resolve flows in effect. As mentioned, it is the player who orchestrates, and in particular, it is the player who initiates. The casino always accepts and always has enough tokens to play. It should come as no surprise that both parties exchange parameters, generate a random number, fetch tokens, exchange a hash, ask for signatures, and deliver an authorized transaction. As for the reveal phase, again, each party does it on its own, but note that the casino sends its reveal transaction first, and then only does the player do the same. We chose to do it in this order because the casino has locked more of its tokens in the commit phase, and so we reckon it has a larger incentive to reach the resolution earlier. By the way, the mitigation strategies are something we are actively looking at as future improvements. After that, the player proceeds with generating the resolve transaction. And although this transaction does not need any signature to pass, the player still adds its own because the Corda system requires one. 4 transactions are here? Sounds like a lot for a single game. How responsive can the system be? Well, with our 2 nodes deployed on AWS and part of the testnet, it turns out that it takes less than 1.5 seconds for a game to complete. Demo time. The game is initiated when I press the spin button and is resolved before the first reel stops. Down there we have added a simple leaderboard which can record your balance of tokens for bragging rights. In terms of implementation, it creates a ledger state with your score, and the transaction that creates it has all your tokens passed by reference, so that the leaderboard contract can confirm the score. States with scores that are no longer relevant are consumed too. Your nickname is stored into a regular SQL table, and so can be deleted without trace. #GDPR.
To deal with unhappy paths, we have designed foreclosure flow. This flow is needed to guard against potential situations where either party could exploit the game. This could be a party quitting the game or a party cancelling the game prematurely. So the flow allows the game to be settled in a fair way, and it uses game timeouts to determine which party could close the game. This could arise if either party did not commit, or they cancel the game, or they don't reveal. In summary, the flow will assemble the input states, which are the game state, commit states, or reveal states, and associated token states. The contracts will verify that the right states are being consumed, the time windows are met, and the correct tokens are being returned. And the final transaction will cancel the game, and the tokens will be returned.
In summary, both parties help to choose the random number. Using commit reveal means that a party can't change its selection after the other discloses. And timeouts mean that a party can't just stop communicating to end the game as soon as it's revealed that it'll be the loser. And we have lockable tokens. Parties start by signing an initial transaction that associates their tokens with the game state, so that after the reveal or a timeout, then the winner can acquire the tokens from the game without the loser's signature. There is still one edge case, where a party notarizes its reveal to prevent the other's timeout, but doesn't then send its notarized reveal to the counterparty. Is this a more general problem in Corda, i.e. what happens if a malicious node doesn't send a copy of a notarized transaction to the counterparties, so that the updates to the distributed ledger are not distributed? One solution, I guess, might be a validating notary, or an observer node to record all the reveals. Another solution might be to change the economic incentive, i.e. if the player had to lock a lot of tokens as a deposit in order to even play the game, then it'd be cheaper to lose the game and get the deposit back than to prevent the game's completion and forfeit the deposit. One more area for improvement is the runtime performance. Each game currently takes a whole second or more. This particular Corda app does a lot, 4 transactions per game. I'd have guessed it ought to be orders of magnitude faster. Still, R3's published benchmarks for a performance-tuned enterprise node show 1,000 transactions per second, and that seems more acceptable.
Thank you for having stayed with us up to here.
Good.
That was good. I like the leaderboard.
All right, so now we've done that bit, do we need sort of 2 minutes of deliberation now?
Sorry, guys.
Or do we need to play the game for a bit first? And very, very close. So I wish we could just sort of sit on the fence and just give it to both of them.
If we took the best parts of both of these, the product that you'd end up with, seriously impressive. with the built-in redundancy, with the risk, with the escrow process, and the node explorer impressed me as well.
Yep.
It's hard to choose.
Yeah. Does the winner get a job at IVNO?
But if somebody can solve random number generation, I'll pay them myself.
And now, while the judges confer, let's see what the individual teams' reactions are. Hello, Team Wizards. How are you getting on? What did you make of that?
I have a couple comments, indeed.
You have a couple of comments. Good comments, bad comments about the other team's presentation?
It's the other team, right?
Oh, that...
I liked the faces of how to pander to the judges. That
was a nice little touch. That's quite political, putting Ryan at the bottom and Richard Crook right at the top. I wonder what the judges will make of that. Hello, guys. How are you doing?
Hey, Martin. Great.
Good.
Good.
I can't wait to find out what you thought of it. How did you find the last 7 weeks? Was it easy? Was it hard?
It was extremely busy, Martin, thanks to you. Yeah, but it was a great journey.
But yeah, it was really, really interesting to see, the stack and what you can achieve with a stack as simple as what we've used. I say simple, but I mean, there's not too many frameworks involved here. And it was really enjoyable. It's really enjoyable to see the end product as well.
And what about you, Florian? How did you find the journey? And was it straightforward, designing it and programming it?
I wouldn't say that. I think it was definitely more complex than I expected. And Corda did not make the job easy for sometimes. But in the end, I definitely agree with Yash. It was a very interesting journey. Like on the personal side, I definitely learned a lot. It was very, very interesting.
So I can't wait to see what the judges say. Let's find out.
They are both working solutions. There's no doubt about it. And therefore, whatever weight we give to working, we do hold working very high. So, but it's not what's going to differentiate these two in this competition because we've got two working solutions. That, by definition, makes this more difficult. After that, we think there is a clear winner. I certainly would agree with Ryan that the novelty of having our faces on the screen, I'll take that fact that they ranked me above Case. That is
lost marks from me.
Yeah. but I think in terms of the fun element, the artistic ability with the artwork, and they've done that. That is awesome. I mean, really, they clearly delineated themselves on the fun aspect. And CordaCodeClub does have a fun element, so I will give them that. The pattern that we saw on the wizard side clearly does solve the decentralized problems, and they've gone into a lot more of the academics of it. But it would appear that CoSMA have solved this in a decentralized fashion. So, I mean, Ryan, from your perspective, looking at CoSMA, is there a weakness here? Is there something in the decentralized design that you didn't like? Not in terms of the code, but in terms of actually, guys, your casino is faultless, or your casino does have a fault.
In terms of decentralized design, I think it's really nice. I think them sharing the deposit process, having the whole escrow, so that is a genuinely decentralized locked escrow token with Casino B or Casino C. That's a really nice architectural network design as far as I'm concerned. There is a hole in their random number generation, but there wasn't a weighting towards how they did random number generation. Clearly, that's a deep flaw in the game itself, but whether we take that into account, I'll take your opinions on that. I think the Wizards have thought about the second order effects, whereas you guys, you built in some really nice redundancy. You did the escrow process. And the Node Explorer was awesome as well. So if you put the two of those together, or the best parts of the two apps together, within 6 weeks, it's amazing what you've done. So well done.
Yeah, like Ryan says, it was extremely close. I think, you know, the way CoSMA used the more decentralized approach, I guess, with sort of like splitting it amongst three casino nodes to sort of hold the token was smart. But like Ryan said, I think, you know, when taking into account second order effects, I think the encumbrance of the token, which can only be unlocked once the resolved game has been revealed and it's been shown that it followed the rules, was really smart. And it's, you know, if you look at this space, it's one of the problems people are trying to solve right now. It's one of the more difficult things where people are trying to sort of, you know, move assets between various networks. And, you know, it really is the key to sort of interoperability in many ways. So, you know, academically or academic wise, it was really, really smart. But, you know, having said that, both efforts were absolutely outstanding. It was really, really close. So well done to both teams.
It feels to me like there is a differential in the Wizards and CoSMA in the decentralized. It's the only thing that we're going to. We know that the Wizards, we know the CoSMAs are going to win on fun, but it's the decentralized aspect that is interesting. From the point of view of the judges, we were given 3 criteria: fun, decentralized, and working. Well, those 3 are not evenly weighted. Working is by far the most important. Following that, it's going to be the decentralized, which is probably half the weight of working, and then the fun aspect, which is CordaCodeClub. So there's got to be some fun. And what we include in that is the UI and the front end aspects of this. Is probably half the weight of the decentralized. So we look at those 3 categories. Undoubtedly, we have 2 working solutions. And normally in these types of hackathons, there's a bit of smoke and mirrors. There's a bit of presentation presentation driven development. But actually, in this case, you can see 2 working solutions, and there's nothing in it between the teams. We know that we've had dropouts from other teams. So these are the 2 finalist teams, and there are 2 working solutions. So we have to split the points between you. And in this game, what we try and do is throw all the points one way or the other to try and get a differential between the teams.
Thanks, Case. I've just received the judge's decision. The results are now in. And the winner is the Wizards. The Wizards have won. Well done, guys. Well done indeed. Guys, what can I say? Congratulations.
Hi, thanks, Martin. Yeah, it was, thanks to the judges. I really enjoyed their analysis. I thought they did that pretty well with the 3 different categories.
Yeah, it's good to see hard work paying off, especially against a strong opponent.
Yeah, it was clearly quite. It really felt like a close run thing, you know. But well done. And for me, it's for you guys. It's all about the leaderboard. I think. Seeing everyone's name.
Yeah, they did not mention it.
They didn't even mention, did they? It's almost as if they were judging your Corda app on its merits rather than on the fluffy, you know, nice to haves.
Especially that the leaderboard in itself is interesting. It's a provable leaderboard. It means when you click the button, it will not just take a number, it will keep a reference to all your tokens so that it's proven that you have at least that many tokens when you enter the leaderboard.
Really? So it's not just, oh, there you go. Well, there you go. It clearly a well-deserved win indeed. Congratulations, guys. Huge commiserations. It was obviously really close.
Yeah, well done to your team. They really did well. It was impressive the work that they did on the decentralization side. They probably invested more time on that and more efforts on the decentralization part, and it paid off. We played a lot on the UX side of things, and unfortunately it wasn't enough. But yeah, congratulations to the other team. I think it's well deserved, and they did a great job on the technical side. It was an amazing job.
The Wizards are the winner. What an incredible result. Congratulations, Team Wizards. You are the winners of this year's Best CordaCodeClub Corda 2020. Well done. And I must say, having witnessed all your efforts over the last 7 weeks, the long evenings and some of the ups and the downs on the way to production, your Herculean efforts have clearly totally paid off. What a well-deserved prize. And Team CoSMA, what can I say? Commiserations. It's clear that it was a close run battle, and I'm sure, having played your Corda multiple times over the last few weeks, there can be no doubt about what an incredible effort you guys put in. Well done. Okay, everyone. Well, I'd like to end this event now with some thank yous. I'd like to thank all the participants. You were absolutely fantastic. Thank you so much for all your hard work. I'd like to thank the judges, Ryan, Richard, and Case. Thank you for today and for being such brilliant supporters of CordaCodeClub. And finally, I'd like to thank R3 for hosting our CordaCodeClub final today and for creating Corda in the first place. Without you, the incredible things we've seen and done today would never have been possible. If you enjoyed watching this competition, then go to meetup.com/CordaCodeClub and join us for the next CordaCodeClub Extended Hackathon.